This is Team Inferno and our project is YouTube data analysis in a Hadoop MapReduce environment. Let's get into the project. The problem is to analyze large amount of YouTube data sets derived from YouTube API. For this, we are using Hadoop MapReduce framework for analyzing those large data sets. And finally, we get the output containing top 5 categories, uploaders, and most viewed videos. Coming to the implementation of cloud features, our application satisfies the following features. The first one is on-demand self-service. In our MapReduce application, we can add as many VMs as requested by the client. Hence, it satisfies the on-demand self-service feature of cloud. The next one is resource pooling. Our application maximizes the shared computing power to efficiently distribute capacity as needed, hence satisfying the resource pooling feature of cloud. The next one is broad network access. Our application can be hosted on web, hence making it accessible to everyone. Also, if any of the computing nodes go down, we have replication to handle the same. If name node goes down, we have secondary name node to make our application accessible to the client. A rapid elasticity. In our application, the capabilities available for provisioning often appear to be unlimited and can be appropriated in any quantity at any time. That is, we can increase the number of nodes at any time. Measured service. Resource usage can be monitored, controlled, and reported, providing transparency for both the provider and consumer of the utilized service. Currently, our service is not commercial, but it can be made a measured service as well. Following are the tasks accomplished in our project. Requirement analysis, in which we research for Hadoop application development. Hadoop multinode cluster setup, in which we use separate VMs to act as a cluster of master and slaves. We also extracted video data using a YouTube API and stored into the Hadoop file system. And we wrote the Hadoop mapper and reducer codes for filtering out top 5 categories, uploaders, and viewed videos. Finally, we developed an UI to visualize the result in the form of charts. We performed unit testing of all the modules along with the development, and finally integration testing was done.
Now let's have a demo of our project. Following is the Hadoop cluster which we have set up for our project. Here the VM1 acts as the master node and the rest of the nodes are the slave nodes. This is the console of the master node. When we execute the JPS command, we can see that these are the daemons running on a master node, which are resource manager, name node, and secondary name node. This is the console of one of the slave nodes. We can see that these are the daemons running when we execute the JPS command, which are the data node and the node manager. Our application is hosted using Node.js server. To make the application up and running, we need to start the server using the command node.js app.js. Currently, the application is hosted locally, and to run this, we need to open the web browser and go to the address localhost 8080. This is the home page for our application. To fetch the data from YouTube, we need to click on Get More Data option. It will navigate us to a new web page. We can select the time frame for which we need the video data. When we click on the Fetch Data button, data will be collected in a CSV format using YouTube Data API. It will take few minutes to retrieve the data. So this is how our data.csv file looks like after being fetched.
Once the data is fetched, we go to Statistics page and click on Analyze Data button. This will run a script on the data collected, in which 3 Hadoop MapReduce jobs are triggered in the background. First job will be for displaying top 5 categories, second job for top 5 uploaders, and third for top 5 viewed videos. This is the script which contains Hadoop commands for running the MapReduce job. This command will run the MapReduce job for filtering out the categories and its count. The next command will run the MapReduce job for filtering out the uploaders and its count. And the last one will run the MapReduce job for filtering out the video name and its corresponding number of views. These commands will sort and display the top 5 categories, uploaders, and viewed videos. The output is then visualized using d3.js on the web page. The first donut chart shows the top 5 categories and the number of videos in each category. The next chart shows the top 5 viewed video names and its corresponding number of views. The table below shows the top 5 uploaders and number of videos each one has uploaded. This marks the end of our project. Thank you.